So we're kind of shifting gears from what we've been doing. This chapter is kind of strange that way. You've got one section that's pretty much all one kind of thing, and then you have the last couple sections deal with a whole different topic. And what we're dealing with is function notation. We're dealing with functions. And we've talked about and dealt with functions before. Function as opposed to relation, that kind of stuff. We've done that. Okay. And we've used function notation before. It's been a while, but we have used function notation before. Okay. Today we're going to use it considerably. And the higher up you go in mathematics, the more you use function notation, the less you use things like y equals. Y equals 2x plus 3 is a function. But when we use function notation, f of x, or g of x, or h of x, or v of t, or a of t, or other things, it is much, much, much more useful. It's easier to work with. They're easier to evaluate. If I want to know what a function is in a particular number, I can plug in that number. Function notation makes it easier to understand that's what I'm doing. And I can do it more, I can do it with different numbers much easier, repeatedly much easier. I can also use function notation in order to represent what I'm talking about. For example, I can have, instead of, for velocity equation, I can use v of t, velocity at time t. A of t, acceleration at time t. And the notation is a description of what I'm talking about. And that's much easier to do with function notation. And we've done evaluation. We're going to use it much more extensively. Composite functions is a combination of two or more functions where the output of one function becomes the input of another function. Composite functions is where you are taking one and sticking it inside the other. Now, there are two notations that are used for composite function, and we say f composed of g. It's a little dot, a little open circle. You will see it. It's in your notes. You'll see it when we get to it in here. It's a little open circle. It looks like a little degree thing. That is technically, that means I'm doing a composite function. That is f composed of g. What that means is I'm taking g of x and sticking it into the function f. That's what a composite function is. I'm taking the second function and sticking it into the first one. And we will do examples of that so you'll understand it when we get there. But that's what the notation is. F composed of g. Okay? F composed of g of x. You need to know that notation. You need to understand that notation. And we will be doing that as we go along when we get to it. Okay. Evaluation is a relatively simple thing. If f of x is 3x plus 2, what is f of 2? And that's how I say it. You say f of x, g of x, h of x. If we put something else in there, we say of that. It is the function f of the variable x. That's where the f of x comes from. So I want to know what f of 2 is. I took the x that was here and replaced it with 2. I take the x that's here, replace it with 2. 3 times 2 plus 2. So f of 2, 6 plus 2, f of 2 is 8. I want to know h of negative 1. So I take x replaced with negative 1. I take x replaced with negative 1. So it's negative 1 minus 4. So h of negative 1 is negative 3. It's negative 1 is positive 1. 1 minus 3 is 1 minus 4 is negative 3. And then I do g of 3. Sorry, g of negative 3. Put negative 3 in for x. 2 times negative 3 squared. So g of negative 3. Negative 3 squared is 9 times 2 is 18. That's what you do. When you evaluate, you just plug it in. And you can evaluate anything. You can plug anything you want into a function. F of m. I'll move that up. So if f of x is 2x plus 3, f of m is 3m plus 2. That's 2x plus 3. 3m plus 2. Yeah, just plug it in. That's all you do. Just plug it in. And like I said, you can do it with anything. G of a. Okay, took x, replace it with a. G of a is 2a squared. You can evaluate anything. That's the nice thing about function notation. You can evaluate anything. You can even evaluate another function. F of g of 1. This is actually a composite function. Technically speaking, this is f composed of g of 1. Those are the same things. That's the same thing. Two different notations to say the same thing. What does that mean that we do? That means we figure out what g of 1 is and plug that inside of f. Okay, so off to the side, I want to know what g of 1 is. G is 2x squared, so that's 2 times 1 squared. So g of 1 is 2. So that means that f of g of 1 is actually f of 2. Because what is g of 1? G of 1 is 2. So f of g of 1 is f of 2. And then I put in 2 in for f. 3 times 2 plus 2 is 8, which we figured out earlier. That's what a composite function is. It's a function inside of a function. Okay, that's a composite function. That's where we stick another function in there. And you can stick another one in there, and you can stick another one in there, you can stick another one in there. You can do all kinds of composite functions. And they do have their purposes. Any questions so far? Okay. I need to go back. Uno momento. And I need to write down what F, G, and H are. X, 3x plus 2, G of x, 2x squared, H of x is negative x minus 4. Because when I get to the next screen, I have not redefined these, so it's still the same f and g and h. If I change what they are, I'll redefine them. I'll say, okay, there's something different. Okay. So I want to find what g of h of 3 is. Well, I need to know what h of 3 is first. I can't take g of something that I don't know. I need to find out what that thing is. So I have to figure out what h of 3 is. Negative x minus 4, negative 3 minus 4. So h of 3 is negative 7. That means g of h of 3 is g of negative 7. Same thing, because what h of negative 3, or sorry, h of 3 is negative 7. So that means I have 2 times negative 7 squared, which is 49 times 2, 98. Excellent. F of g of negative 2. So I need to find out what g of negative 2 is before I can take f of that. So g of negative 2, 2 times negative 2 squared, which is 4 times 2, which is 8. So this is f of 8. That's what g of negative 2 is. G of negative 2 is f of 8. G of negative, sorry, f of g of negative 2 is f of 8. G of negative 2 is 8. Which means that I have 3 times 8 plus 2, which is 26. So f of g of negative 2 is 26. And the next one, I have composite functions made of 3 functions. Here's the rule when you're working with composite functions. Work from the inside out, which is what I've been doing. You work from the inside out. If I have more than one, I just still keep doing the same thing. I work from the inside out. I need to figure out what f of negative 1 is first. So the first thing I do is I figure out f of negative 1. F of negative 1 is 3 times negative 1 plus 2, which is also negative 1. Fancy that. So that means h of g of f of negative 1 is h of g of negative 1. Because f of negative 1 is negative 1. So what do I need to do? I need to find g of negative 1. G of negative 1, 2 times negative 1 squared, is 2. So this is actually h of 2. Which is negative 2 minus 4, which is negative 6. You work your way from the inside out. You have a composite function, you work your way from the inside out. Okay, still the same f, g, and h. I can add, subtract, and multiply functions. Okay. F plus h of x is actually f of x plus h of x. That's what that is. H of x plus f of x. So that means I have 3x plus 2 plus negative x minus 4. Then I combine up like terms. 3x plus negative x is 2x. 2 plus negative 4 is negative 2. Algebraic manipulation. That's what it is. It's algebraic manipulation. Now, the next one's a little trickier, or can be. It depends upon how you look at it. Doesn't matter. H plus g of 5 is h of 5 plus g of 5. I have choices. I can combine h and g together first, and then plug in 5. Figure out what h plus g of x is, and then plug in 5. Sometimes it's better to do that. Sometimes just go ahead and figure out what h of 5 is and g of 5 and add them together. What is h of 5? I plug in 5 for that. So h of 5 is negative 5 minus 4. Plus g of 5 is 2 times 5 squared. Plug into 5 into h, plug in 5 into g, figure them out, add them together. So this is negative 9, and this is 50. So that's 41. Okay, so far so good. It's not, like I said, it's algebraic manipulation. If you understand function notation, you get it, it's actually not that bad. You gotta understand what you're being asked to do. F minus g of x is f of x minus g of x. So that's 3x plus 2 minus 2x squared. Can't really do much to that except get rid of the parentheses. 3x plus 2 minus 2x squared. And really ought to put it in standard form. Move the x squared to the front, negative 2x squared plus 3x plus 2. That should be your final answer. You're combining things up and put them in standard form. Squares, x's, numbers. G times h of x, which is, so g of x times h of x, 2x squared times negative x minus 4, so negative 2x cubed minus 8x squared. Just multiply and distribute. F minus h of 2. F of 2 minus h of 2. So f is 3x plus 2, so that's 3 times 2 plus 2 minus negative 2 minus 4. So this is 8 minus negative 6. 14. Yeah, I think so. Hope so. F times g of x, which is 3x plus 2 times 2x squared, because it's f of x times g of x. So that gives me 6x cubed plus 4x squared. So far, so good. Okay, this one, h over g of x is h of x over g of x. So that's negative x minus 4 over 2x squared. And that's my answer. I can't do anything else to that one. Can't simplify it. Can't do anything. It's done. If you can simplify, simplify, but you can't simplify this one, so you're finished. Now here's the one that screws everybody up. This is the one that gets everybody screwed up. It's really not nearly as complicated as it looks. 3f of x means 3 times whatever f of x is. 2g of x is 2 times whatever g of x is. That's all that means. If I have something out front, it's 3 times that function. So I have 3 times 3x plus 2. That's 3f of x. 3 times f of x. Plus 2 times 2x squared. 2 times g of x. That's what those numbers, when you have something in front of a function, it's just that number times that function. That's all. That's all that is. Distribute 9x plus 6 plus 4x squared. And once again, you should move your x squareds up to the front to make it look pretty. Because we want things to look pretty. Once again, that's probably the one that screws the students up the most. Is that one there, or one of them? And it's just 3 times whatever f is, 3 times whatever g is. Put a number in front, it's what it is. You have negative 2f, then it's negative 2 times whatever f is. Okay. F over h of negative 2 is f of negative 2 over h of negative 2, which is 3 times negative 2 plus 2 over negative 2 minus 4, which is, let's see, negative 6 plus 2 is negative 4. I get negative 4 over negative 6, which is 2/3. Because you always simplify. Yes.
Negative 2 is supposed to be just a third.
Oh! Thank you for catching it quickly. Negative 4 over, that should be a negative 2, which means that I have negative 2 here, which gives me positive 2 for my answer. Better? Yeah, everybody screws up once in a while. It's what you do after you screw up that counts. Okay, now we get to the compositions. F composed of G of X. Remember, F composed of G is F of G of X. That's what that means. I told you, wrote it down. That's what a composition looks like. That little open dot, that means composed of. That means I'm taking F of whatever function is up following that. It's F composed of G. That means I take G of X, stick it into F, which means I'm taking F of 2x squared. Because what is G? It's 2x squared. Which means that I'm taking 3 times 2x squared and adding 2 to that. So I get 6x squared plus 2. That's my answer. Okay, G composed of H of X. That's G of H of X. That's what that means. G composed of H is I'm taking G of H. Which means I'm taking G of negative X minus 4. And G is 2x squared. So that's 2 times negative X minus 4 squared. That's what that means I'm doing. Because G is, I do take whatever I'm taking G of, I square it, then I multiply it times 2. That's what that function is. I take the number, square it, take the object, square it, multiply it times 2. That's what G is. So I have 2 times x squared plus 8x plus 16. That's what you get when you square it out. If you want to do negative x minus 4 times negative x minus 4, FOIL it out, combine up like terms, you will get the same thing. But I'm squaring. What do you do when you square? Square the first term, get x squared. Multiply the 2 and double it. I get 8x squared. Square the last term. Okay? And then I do 2 times that. So I have 2x squared plus 16x plus 32. F composed of F of 2. This is H of F of 2. Now we figured out we've done F of 2 like 3 or 4 times. F of 2 is 8. So that means I have H of 8. Because we have done F of 2 several times, we have figured out that F of 2 is 8. We've done it. If you look at your notes, we've done it like 3 times already. So H of 8 is negative 8 minus 4, negative 12. Now, there is another option for doing h composed of f of 2. There is another option for it. What you can do is figure out what h composed of f of x is, do it in terms of x, and then plug 2 into that answer. And that works as well. Sometimes that's what you want to do. Not very often. Kind of depends on the equations that are involved. Okay? Depends on how many times you're going to do it. If I'm going to do h composed of f of 2, and h composed of f of 3, and h composed of f of 5, and h composed of f of -6, if I'm going to plug in several numbers and do h composed of f, I'm going to figure out what it is in terms of x first, and then just plug those numbers into that because that will be easier. All depends upon what I'm going to do. Your turn. Okay, most people seem to have the first page done. G of -5 is 3 of -5 squared, which is 75. H of 3 is -3 plus 5, which is 2. And then the easy one, f of v, it is 2 times v minus 1. Just plug in v, and you're good to go. H of w, same thing, -w plus 5. And this is where it starts to get a little more complicated. F of h of -2. Figure out what h of -2 is. H of -2 is -2 plus 5, or 7. So this is actually f of 7. So 2x minus 1 is what f is. So this is 2 times 7 minus 1, also known as 13. And at g plus f of 1, once again, I can figure out what g of x plus f of x is, and then plug in 1, or I can find g of 1 and f of 1 and plug them in. This is the same thing as g of 1 plus f of 1. So that means I have g of 1 is 3 times 1 squared, plus f of 1 is 2 times 1 minus 1. So that's 3 plus 2 is 5 minus 1 is 4. Next one, f minus h of x. F of x minus h of x. So I have 2x minus 1 minus -x plus 5. Distribute my negative. So that gives me 3x minus 6. F minus h of -1 is f of -1 minus h of -1. So that's 2 times -1 minus 1 minus -1 plus 5, which is -3 minus 6, or -9. Yes?
So for the last one, do you have to flip the side?
This one here?
Yeah.
I just distributed the negative to make sure to combine up like terms properly.
Okay.
As long as if you got the same answer, that's okay. I just, like I said, distributed the negative to combine it to make it easier to combine up like terms. And then h times f of x is h of x times f of x, which is -x minus, -x plus 5 times 2x minus 1, 2x minus 1, FOIL. Negative 2x squared plus x plus 10x minus 5. So I get negative 2x squared plus 11x minus 5. Did I get when I do that? Questions? It's not complicated, but it does require some serious algebraic manipulation. Look, it's your turn. Again, still do those. Okay, let's go ahead and do these. Negative 2 of f of x minus 3 of h of x is negative 2 times 2x minus 1 minus 3 times negative x plus 5. Negative 2 times f of x minus 3 times h of x. That's what that means. Distribute. Negative 4x plus 2 plus 3x minus 15. Combine up like terms, you get negative x minus 13. Next one, g over h of x is g of x over h of x, which is 3x squared over negative x plus 5. And you can't really do anything to that. So you're done. F over g of 4 is f of 4 over g of 4, which is 2 times 4 minus 1 over 3 times 4 squared, which is 2 times 4 is 8, so I get 7 over 4 squared is 16 times 3 is 48. 7 over 48 cannot be simplified. And then we get to our compositions. F composed of h of x is f of h of x. So that means it's f of negative x plus 5, which means it's 2 times negative x plus 5 minus 1. Distribute the 2 and combine like terms. Negative 2x plus 9. G composed of f of x is g of f of x. So that's g of 2x minus 1, which is 3 times 2x minus 1 squared, which is 3 times 4x squared minus 4x plus 1, which is 12x squared minus 12x plus 3. And then last but not least, h composed of f of 3, which is h of f of 3. Figure out what f of 3 is. That's 2 times 3 minus 1, which is 5. So this is h of 5, which is negative 5 plus 5, which is 0. Zip, zilch, nada. The big bagel. Questions? Most excellent.